Hello again, my friends. If you are here for the very first time and you don't already know, I'm Islam Shaban with PC-based PLC programming using TwinCAT3 tutorial. This is exactly where you want to be to learn more about the TwinCAT3 and how to program a bit of PC-based PLC. In this episode, we will discuss the real-time / tasks configuration, which is I found one of the most important topics in this tutorial. But to do so, first we need to have better understanding of how actually the TwinCAT3 interact with the Windows and how Windows gives TwinCAT the chance to work under real-time conditions. I'm not gonna bother you with all the unnecessary details of how TwinCAT3 works, but I'm gonna simplify the main concept so when you start to configure your system, you already had the required information. Ready? Let's start.
As you already know, Windows is a general-purpose operating system, not a real-time operating system. As like any operating system, Windows is a software to interface between the user and the computer hardware, like processor or the memory. Or to be more specific, it is an interface between the running applications and the hardware. Running applications like Microsoft Office, Internet Explorer, games, and Visual Studio. As all applications are running via the operating system, to get an interface with the hardware, that means the operating system, Windows in our case, decides the percentage of each application's process share on the hardware like CPU and memory. The operating system decides which process has the priority to be executed right now and which process should wait. In other words, the process of the applications might interrupt each other, so some process could be stopped in favor to execute a process from other applications that happen based on some algorithms built in the operating system itself. And you might be already experienced this situation by yourself. When a running application in your PC becomes slow when another heavy application starts working, for example, antivirus application or a heavy game. Such behavior is quite okay with a non-real-time application. But on the contrary, such behavior for the field of industrial automation and in the field of automation in general is undesirable. If you're wondering why, let's assume a hypothetical scenario that you're controlling a fan corresponding to a temperature transmitter and a start signal command from the controller to the fan gets interrupted because the antivirus application wants to run. Of course, you and your automated system will not like this kind of interruption.
The faster the process gets executed, the better the real time becomes, as you can collect much more data from the hardware in less time. So the time delay between the input signals, the temperature transmitter in this case, and the output signals, the start command to the fan, becomes less, so the system can react immediately on the system input, which means the whole process latency becomes less. The less latency, the better the system. That's why we need more and more powerful CPUs to control the complicated system. As in the modern complicated system, we have many processes that need to be executed parallel in a short time. That's why we utilize the multi-core CPUs in the industrial automation field. The industrial automation application requires a real-time behavior. The system knows upfront how much time it will take to execute a certain process. Also, the processes do not interrupt each other. That means we need a direct access to the hardware, the CPU for example. But by understanding the difference between the real-time and non-real-time application, maybe you start asking yourself how running the TwinCAT software on Windows operating system could guarantee the real-time behavior. TwinCAT3 XAR has to run under a real-time condition so that It won't be interrupted by other tasks on the computer while it's busy executing machine control logics. To better understanding this, you need to know the execution mode of the Windows.
Windows has two execution modes. It's called rings, ring 0 and ring 3. Ring 0 is kernel mode, which is where all drivers and some internal Windows code runs. And ring 3 is a user mode, which is where normal Windows applications run. The TwinCAT3 runtime also runs on the ring 0. That means TwinCAT gets direct access to the hardware resources. That means the Windows normal applications are not able to interrupt the TwinCAT tasks, as the TwinCAT3 runtime will not rely on Windows to manage its tasks. TwinCAT gets the real-time privileges. TwinCAT works with a kernel mode scheduler which distributes CPU time to TwinCAT tasks and Windows itself. Seeking for simplification, let's assume the CPU has a timer with a base time that varies from 1 millisecond to 50 microseconds. That base time is the time frame for a constant interrupt where a scheduler buzzes Windows and provides time for TwinCAT real-time tasks.
But what exactly the TwinCAT tasks? Tasks is a time frame for TwinCAT to do some essential things. For instance, running the PLC software, interface with the hardware via I/O. So each time, for example, you wanted to write a PLC code either using IEC standard or C++, you need to identify a task to run your code, identifying a task by name and priority and a cycle time. The cycle time is the most important part when identifying a task. The PLC cycle time is the time needed by the CPU to scan the I/O signals and run the PLC code. Long story short, the PLC cycle time determines the program repetition frequency. So seeking simplification, at this moment we can consider the task cycle time as the PLC cycle time. The TwinCAT task is the part who gives the cyclic effect to your code. And as you maybe know, any control code needs a cyclic part to repeat the code execution. You can find this part as OP1, for example, in Siemens PLC, or the infinite while loop in the other systems. Keep in mind that TwinCAT tasks are a real-time tasks, so it needs a real-time CPU. Also, TwinCAT3 provides extensive support of multi-core systems. Alright, so enough talking, and let's see how to configure the real-time properties in the TwinCAT project.
In the previous episode, we already created the TwinCAT XAE solution, also the PLC project. And for creating the PLC project, we selected the standard PLC template, which is contain a PLC task linked to the main BOU. So first things first, let's configure the real-time properties. Here under the system node, double click on the real-time. On this window, you can manage the real-time settings for the TwinCAT runtime. The default settings have only one core. So first, we need to read the number of cores of our target. That target could be the actual PLC device, or as in our case right now, I'm using my local machine as the target to run the runtime, as the target tab refers to local. Okay, click read from target. TwinCAT detect my PC 7 cores. The number of cores may vary based on the type of the CPU in your PC. I already previously configured my CPU to have 6 shared cores between TwinCAT and Windows. So yes, the TwinCAT and Windows can use the same core. The percentage is 80%. 80% of the core time is utilized to do the TwinCAT task, and the remaining 20% is assigned to the Windows tasks. The 7th core is isolated, which means it's 100% dedicated to executing the TwinCAT tasks. And I have found that mixing Windows and TwinCAT3 on the same core might cause problems. So if you have a machine with more than one core, I totally recommend allocating at least one isolated core for TwinCAT. You can configure your CPU cores also by clicking the Set on Target button. Then you specify how many cores you want to configure it as isolated core. Remember, the isolated core is fully dedicated to the TwinCAT, so Windows will not see it. If you hit Set, the system should reboot. After rebooting, the isolated core shows up. Then you can select it to run the TwinCAT tasks, 100% dedicated. Of course, you can isolate and use more than one core if it's required by the application. Then you can configure the base time of the CPU core, which varies from 1 millisecond to 50 microseconds. Please note, the TwinCAT cycle time can be a multiple of the base time. If not required by the application, the base time shouldn't be set below 1 millisecond. It could slow down the Windows system performance without any noticeable performance advantages in the real-time kernel. Base times far below 1 millisecond require PC system with adequate performance. Setting base time to none means that you can execute only tasks that do not need real time. So leave it now 1 millisecond. In the table below, you can find the tasks that include in your application. For example, PLC tasks that been created by the standard template. This task will be responsible for executing our PLC program. The task is already assigned to the real-time core number 7. And it is the only real-time core in our solution right now. But for instance, if we use more than one core, like this core, so now we have two cores, you could select in which core you're gonna assign this task. In other words, in multiple tasks and multiple core system, you can manage the performance of the system by distributing the workload among the cores. That's now easy, right? Notice the task cycle time. Although the CPU core base time is 1 millisecond, the task has 10 millisecond cycle time. That means the PLC code will be cyclically executed each 10 milliseconds. And you have to design your code in such a way it never exceeds the assigned cycle time. As if the PLC code execution exceeds the cycle time, the PLC will stop and switch to an error mode. The question now is, how can we configure the task cycle time? Click the task node and select the PLC task. The most important field in this window is the cycle text. By modifying the number of cycle texts, you can change the task cycle time. Remember, the task cycle time is a multiple of the base time. The default value is 10 cycle texts, which makes the cycle time 10 milliseconds. It's obvious that the cycle time is a result of multiplying cycle texts by CPU core base time. Remember, the base time of our CPU core is 1 millisecond. So by changing the cycle text to 5, the cycle time changed to 5 milliseconds, for instance, or even one cycle text gives 1 millisecond cycle time. I'm gonna keep the default value, but now you know how to configure it, right? Alright, then we now know how to configure the real-time properties and the task cycle time. So let's see how that gives a cyclic effect to our PLC code. I'm gonna write a simple silly piece of code just to demonstrate the cyclic behavior. Open the main program. The upper part is where you can declare some variables. Let's declare a variable called, for example, test. It doesn't matter now the name. And his type is double integer. Here, in the lower part, is the actual place to write your code in. To demonstrate the cyclic behavior, I'm gonna make the variable increment every cycle. So if you're not familiar with the structured text, do not worry. You will find a sufficient cover for this topic in the upcoming videos. Back to our code, every 10 milliseconds, every cycle time, the variable will increment by 1. Maybe you're now wondering how the code will repeat every 10 milliseconds, although we didn't write any loop in our code. The answer is laying here. You will find the main program is already linked to the PLC task as a reference task. Yes, exactly. As you said, the PLC task already has a 10 millisecond cycle time. That's how we configure it, which is mean the main program will be executed every 10 milliseconds. Alright then, let's see how the code will work. Finally, some fun. The first step is to activate the configuration by clicking on Activate Configuration. In this step, TwinCAT compiles your code and sends the source file to the target system. In our case now, the target system is my local PC. Hit OK. TwinCAT asks if you wanted to start the system in run mode. Hit OK. Notice the taskbar shows the current status. Then log in to the PLC. In this dialog box, asking whether the application should be created and loaded, hit yes. The PLC project is loaded into the controller. The engineering environment is now in online mode, but the PLC module are not yet in run mode. To run the PLC project, click on Start PLC. Notice how the test variable gets increased each cycle. Alright then, let's make it more fun. What if we have two tasks with different cycle time in the system? I'm going to create a second task with a faster cycle time. To create a new task, right-click on the task node, add new item. Do not bother yourself in this stage by the difference of the task types. Keep the default type. Give it a name. Let's say PLC fast and hit OK. Now we have two tasks. The PLC task, the default task in the standard template, and the second one which we just created now. Configure the fast task to be 5 millisecond cycle time. Remember, the default PLC task already has 10 millisecond cycle time. Let's also create a second main program. Right-click on the POU folder, add POU. In this pop-up window, you can select either to add a program or function block or function. In the upcoming episodes, we will cover in details the difference between all these objects. We're gonna select the program object because it's the only item that has the ability to be linked to the tasks. Give it a name, let's say fast main. Hit open. Underneath the POU folder, you can find the new program block. I'm gonna write the same code in the fast main, but just with a different variable name. Now, there is an extra step remain, is to link the fast main program to the new task PLC fast, so the program gets executed every 5 milliseconds. To do so, first we need to add the new task as a reference task in our PLC project. Right-click on the PLC project, add reference task. In the pop-up window, you can see all the tasks in the task node. Select the PLC fast and hit open. The reference task has been added in the PLC project tree, but without any linked program yet. To link the program, right-click, add existing item, select the fast main, hit OK. In the PLC project tree already shows that the new program is linked to the reference task PLC fast. So let's run the code. But before we start the PLC, we want first to monitor the two variables side by side to compare their values. I'm gonna add them to the watch list. The watch list is a helpful tool for monitoring. We often use it in debugging. Right-click on the variable in the online view and select Add to Watch. Do the same to the other variable, then hit Start the PLC. We can see the variable in the fast main has almost double the value of the other variable because it runs faster due to the cycle time of the fast main is 2 times faster than the PLC task cycle time.
Now, after this simple example, I believe you got the sense of the cyclic behavior of the system. Till this stage, we covered the basic knowledge you need to start interface with TwinCAT. In the upcoming videos, I will cover much more essential and exciting topics as well. See you next episode.